Hello everyone and welcome back to ZipZip Academy. And today's topic is vectors. We're going to learn about vectors. So we know that a vector is something which has magnitude and direction. For example, we have force. So a force has a magnitude as well as a direction. So for example, there is a force of 5 Newton. So this force will be applied either in this direction, either in this direction, in any direction it can be applied. So this means that a vector is a quantity which has a magnitude and a direction. Okay, so for example, there's a body of mass m kept on a surface, and there are two forces being applied. One is 5 Newton over here and one is 3 Newton over here. So we're going to get a net force of 2 Newton, which is going to be over in this direction, because this is the force which is more and this is the force which is less. Okay, so this was the easy way of finding a resultant force. So in other things also we can find resultant force, like if there's a body and there are two forces being applied for 3 Newton over here and 2 Newton, and find the resultant net force. So we'll find it as 5 Newton in the right. Simple. So this was the easy way of finding the resultant. Now if there are forces on a body of mass m, and there is one force being applied in this direction and one force being applied in this direction, then what is going to be the net resultant force is going to be our main question. So for these kind of questions, there is a law known as the triangle law of vectors. Okay, so there is a triangle law of vectors which we are going to learn. So the triangle law says that if two vectors are arranged as two sides of a triangle, then the third side will be the net resultant vector. For So we take this as an example. So if this is the first side and this is the second side, then the third side will be the net resultant force. Simple. So if we need to find, or if we assume the values, this as 3 and this as 4, and they tell us to find the net resultant force, then we can easily find it by Pythagoras theorem, like this 3, this 4, then and this angle is 90. So we can find it by a square plus b square is equal to hypotenuse square, which will be 5 centimeter. So we got the magnitude as 5. So this is the triangle law. Now let's see another situation. This was at a 90-degree angle, but now if the triangle is formed like something like this or something like this, then how will you find the third side? The question is. So in this case, there's a formula which is being derived. I'll show you the derivation. So first, let's name these sides as this is A, this is B, and this is C. And we extend this and make dotted line and make a new triangle where this angle will be 90-degree, and we'll name this as D. Okay, so we got a new triangle which we can name as triangle ABD. Okay, we got this triangle ABD. So in this triangle ABD, if we apply the Pythagoras theorem, then we'll get as BD square plus AD square is equal to AB square. We got this as a formula. And another formula can be in triangle BDC. BDC, which will be BD square plus CD square is equal to BC square. We got these two formulas. Okay, we got these two formulas. So in this formula, we can get also two more formulas. So AD is equal to AC plus CD. Okay, we got this also. And if we name AC as vector A and BC as vector B, also in this triangle, if we take this as theta, and in this triangle, if we take this as theta, okay. So in this sine theta will become BD perpendicular by hypotenuse BC. Okay. So we know that BC is nothing but B vector B. So we can tell that vector B sine theta is equal to BD. Okay. And cos theta will become CD by BC. BC is nothing but vector B. So it will become B cos theta is equal to CD. Now we got this. Now we can substitute these values of CD and BD in these equation. So if we substitute the values instead of BD, we can put B sine theta. So B sine theta whole square plus, I told you that AD would be equal to AC plus CD. Okay, and AC is vector A. So we'll do vector A plus CD. CD is B cos theta. Okay, whole whole square. Okay, and AB would nothing be but resultant. So AB is nothing but the resultant force. We got this because if we look at the triangular law of vectors, we'll get that vector A plus vector B we took as two sides of a triangle. Then the third side of this triangle ABC will be the resultant. Okay, so instead of AB we can write R square. So if we expand this equation, we'll get B square sine square theta plus A plus B cos theta A plus B cos theta whole square. So it will become A square plus B square cos square theta plus 2 plus 2 A B cos theta. Okay, is equal to R square. Okay, and if we rearrange this formula as A square plus B square sine square theta plus B square cos square theta plus 2AB cos theta is equal to R square. Now in this part, if we take B as common, so what will it become? It will become A square plus B square sine square theta plus cos square theta and rest so on. So we know that sine square theta plus cos square theta is nothing but 1. So we got in the end the equation as A square plus B square plus 2AB cos theta is equal to R square. So R will become root A square. Understood? So we got the formula of resultant in this whole derivation. So the derivation was a bit lengthy, but you might have understood how this resultant came. And for finding the resultant, this is the easiest formula that you can use. So if I mention the values, so theta is the, so this is a, this is b. Here a and b are the magnitude of the vectors. Theta will be the angle between the two directions of the vectors, so this angle. Okay, and yeah, and this is going to be the resultant. And if you need to find the resultant's angle with a, taking this as alpha, if you need to find the value of angle between the resultant and the vector a, you can find it with this formula, where, which is tan alpha is equal to b sine theta upon a plus b cos theta. Okay, so if you need to find this angle, you can use this formula, but this is along the angle of resultant with vector a. If you need to find the angle of resultant with vector b, then the formula would become just the opposite, which will become a sine theta upon b plus a cos theta, just the opposite of this. Okay, so these are the important formulas for vector calculation. If you want me to make a video on the questions related to vectors, please write it in the comment section. So thanks for watching today's video. I hope you understood the derivation of the formula and how to apply it, and the triangle law. You are watching Zip Zap Academy, signing off. Bye guys, and thanks for watching.